Hey everyone, and welcome to The Explainer. Today, we're jumping right into a really fascinating lesson straight from the Academy curriculum. We're going to explore the absolute ultimate physical showdown, light versus sound waves. I'm talking a heavyweight bout. So let's unpack the hidden mechanics of the world around us together, all right? Okay, let's dive into this. Here's our roadmap for the lesson. We'll kick things off with the thunderstorm mystery, then meet the contenders to figure out the what, look at mediums and vacuums for the how, and jump into the speed race to understand the why. Then we'll wrap it all up with some real-world wave examples, and finally touch on education, morality, and peace. All right, Section 1, the thunderstorm mystery. Now, understanding light and sound isn't just about, passing your next 8th grade science test. It's actually the fundamental science behind everyday tech we all use, like microphones and lasers. It also explains the everyday magic of nature. So here's the ultimate mystery we're going to solve today. Why do you see lightning before you hear thunder? I mean, you've all experienced this, right? The sky flashes, and then you just kind of stand there waiting for the rumble. Have you ever really stopped to think about why that delay actually happens? Keep that question front and center in your mind. Now, the source material for our explainer today actually roots its scientific exploration in a scripture from Matthew. He who has ears, let him hear. The lesson presents this really interesting idea that we were created to experience both light and sound, with each serving entirely unique purposes in our lives. It's a perspective that bridges our physical senses with a grander design, and it perfectly sets the stage for our scientific investigation. Which brings us to Section 2, Meet the Contenders. The what? It's time to officially meet the two main subjects of our scientific showdown. You see, light and sound might seem kind of similar because they both travel in waves, but fundamentally, they're completely different beasts. Let's introduce them properly. In the first corner, we have light. Light waves belong to a heavyweight class called electromagnetic waves. I really want that word to stick with you, electromagnetic. The ultimate superpower of an electromagnetic wave is that it can absolutely travel through a vacuum. It doesn't need any matter to hitch a ride on. It can shoot right through the completely empty void of outer space. And in the second corner, we have sound. Sound waves are categorized as mechanical waves. Unlike light, a mechanical wave is totally dependent on its environment. It absolutely requires a physical medium to travel. It has to have something to physically bump into, whether that's the air around us, the water in a pool, or even the solid wood of your desk. Bottom line, no medium, no sound. Moving right along to Section 3, mediums and vacuums, the how. Let's figure out exactly how these waves actually move through our universe. And this brilliantly illustrates the core difference. The type of wave completely dictates how it interacts with the environment around it. So on the left, you see light. It travels anywhere, even perfectly empty space. But on the right, sound is basically trapped unless it has matter, like air or water, to move through. If you take away the matter, sound is instantly stopped dead in its tracks. But light, it just keeps right on going. All right, Section 4, the speed race, the why. Let's get to the real reason we experience these waves so differently. It literally all comes down to a staggering difference in speed. 300,000 kilometers per second. Just let that absolutely massive number sink in for a second. That is the blistering speed of light in a vacuum. Honestly, it's so extraordinarily fast that our human brains genuinely struggle to even comprehend it. In just one single tick of a clock, a light wave can travel 300,000 kilometers. Now, what's really interesting about this slide is the dramatic contrast. 343 meters per second. That is the speed of sound traveling through air. To put that into perspective, comparing 343 meters to 300,000 kilometers is like comparing a snail to a rocket ship. Sound is just incredibly slow compared to the lightning-fast speed of an electromagnetic wave. So let's synthesize all this fantastic data right here. This table holds the absolute ultimate secret to solving our thunderstorm mystery. Light is electromagnetic, travels at roughly 300,000 kilometers per second, and needs absolutely no medium. Sound is mechanical, travels at a mere 343 meters per second, and strictly needs a medium. The whole shebang is right there. Section 5, real-world wave examples. Because, hey, science isn't just about staring at numbers on a page. It's the explanation for what we see and hear every single day. Let's walk through these 3 fascinating real-world examples from our source lesson. First up, the thunderstorm mystery. Because light travels at that insane 300,000 kilometers per second and sound only at 343 meters per second, the light from the lightning strike reaches your eyes almost instantly. Meanwhile, those much slower sound waves of thunder, they take precious seconds to reach your ears. Boom, mystery solved. Second, outer space. Imagine a massive explosion in space. You would absolutely see the bright flash of light because electromagnetic waves travel through a vacuum. But it would be completely silent. No way you'd hear a thing. Astronauts have no medium, like air, up there to carry mechanical sound waves. And third, think about a massive stadium concert. The visual flash of the stage lights reaches your eyes fractions of a second before the boom of the speakers actually reaches your ears.
All right, everyone, time for a quick homework check. The Smart Academy lesson wraps up the physics portion with 5 key questions. Let's actively apply what we've just learned and conquer this homework together.
So the crucial point is that you now have the exact framework to answer these confidently. Number 1, light is an electromagnetic wave. Number 2, sound is a mechanical wave. Number 3, sound cannot travel in space because space is a vacuum and completely lacks a physical medium. Number 4, lightning appears before thunder simply because the speed of light entirely outpaces the speed of sound. And finally, number 5, light is vastly faster. Look at that! You have completely mastered the physics of this lesson. Great job. Now, let's move into our final section. Section 6, Education, Morality, and Peace. The source material does something really quite unique here. It bridges this entire physics lesson into an overarching philosophical and spiritual framework that actually governs their whole curriculum. As presented in the text, the Smart Academy philosophy is built on intentionally intertwining biblical morality with education. They frame their educational approach around this idea that learning the physical mechanics of the world, like, light and sound, should always be paired with learning moral navigation.
And they base this directly on scriptural foundations. The text highlights Romans 8:6-7, noting that it promises peace of mind to everyone who keeps their mind spiritual. The Academy states that this is their direct experience and the experience of people who actively engage with their educational content. Which leads to the central argument of the curriculum's philosophy. Education without morality will hurt. The text argues that simply acquiring scientific smarts or, academic knowledge without a grounding moral compass ultimately leads to destructive outcomes in life. And the lesson ends on this incredibly provocative question for the student. What's the point of being smart and supposedly educated if we continue to make bad choices that hurt? It really challenges the learner to consider the connection between a scientifically educated mind and a peaceful, morally grounded life. It's certainly a deep and complex thought to leave you with after decoding the mysteries of the thunderstorm. Thank you so much for joining me for this explainer, and remember, keep asking those big questions.